Hello there, my name is Harvin Analaki Krishnan, metric number EA18180. I'm grouped together with Selva, and we are from section 1P of the microprocessor class. And for today, we'll be talking about our mini project. I'll be talking about the coding part, and Selva will be talking about the Proteus simulation part. So stay tuned if you want to see the whole video. So what we did was we actually created a mini project on basically showing the voltage and the temperature of using the LPC2138 microcontroller. So basically what we envisioned was the our microcontroller together with all the devices are able to show both the voltage and also the temperature of a certain thing, and that you can see how it goes in the simulation part later. And for now I'll be talking about the coding part. So you can see the header file that we use is the lpc213x.h. We use lpc2138 because it's in the kill software, and it's also in the Proteus software, so it makes us easy to code and easy to simulate. And the next is the include 16 times 2 lcd.h, and the 16 times 2 lcd.h is actually the header file for the LCD. So we defined all the values needed for the LCD in this part. So this coding is actually divided into four main parts, which is the void v-read, the void t-read, and our two outputs, which is the unsigned integer ADC6 and the unsigned integer ADC7. So let's go through all those four parts. Now the void v-read is actually the reading of the voltage. So you can see we have defined it to show the voltage value on the LCD. So not really a lot to talk about. We actually set the ADC value to such so that it does perform its task in displaying the correct voltage value, and if it goes over a certain amount, it will show critical blank, as in the amount of voltage. If it goes over the recommended or over the set value, which is, I think it's set at 10 voltage. So if you go to the void t-read, the t-read part is the read of the temperature part. As I said before, our project is divided into two parts, the voltage and the temperature, and we want to switch in between those two to check out the values when a certain situation or a certain requirement is fulfilled. So this is the coding for the temperature part. As you can see, coding for, well, basically a little bit by little, it's increment, and I have set the max temperature measurable to be at 1286. So if you go above 1286 using the thermocouple, it does not detect anything above that. I've also included the negative temperature coding. So if the K thermocouple, we set it to go lower, it will show as negative. And the same with the voltage part. The temperature part also has a critical thing where if it goes a certain amount of temperature, it will show critical and the value. So as the maximum value is 1286, so it will show critical after the 1286 degree Celsius temperature has been achieved. Oh, excuse me. Now the ADC6 and the ADC7 is actually what it will show in the on the LCD display. So that's the coding we have made it so that it will follow its temperature, and the voltage and the temperature part. As you can see here, this is the LCD one. So we did bit by bit to show on the LCD slide itself. So that is all from my part, and you will check out Selva for the next part. Thank you.
Hello, my name is Elbabar, team entry number EA18048. And now I'm going to continue the presentation for the simulation part. So this is our circuit that we're using for this project. So let me stop this first. So we're using LPC2138, and we're using switch 1 over here, voltage divider, potentiometer here. So this one is alarm. For alarm using LED. So we have LCD thermocouple. So this is thermocouple. So thermocouple is actually bipolar temperature sensor that generates voltage uh, that changes over temperature. So here we're using AD595. So this one is actually monolithic instrumentation amplifier with inbuilt cold junction. What this means is actually this one is it's like thermocouple conditioner. So that's all. So let's try and run this simulation. So as you can see, we have output here, output display. So when we close the switch, it will display the reading for temperature. So when we open the switch, it will display reading for voltage. And you can see here it shows critical and the alarm will turn on, or in this case LED. So the problem we have encountered in this simulation is whenever we try to change the input, like I'm showing here, the output it won't change. It stays the same. So I'm trying to change the input. So this is the problem we are having right now. We couldn't troubleshoot the actual cause of the problem. So we, our assumption is there could be some things that we could have missed in the coding. So that could be the reason why we having this problem. So that's all from me.